Example 3. A cylindrical tank has a height of 12 meters and a radius of 4 meters. Suppose the water tank is half full of water. Determine the work required to empty the tank by pumping the water to the level 4 meters above the top of the tank, where rho is the density or 1,000 kilograms per cubic meters, and g is the gravity constant, which is 9.8 meter per second squared. First, we draw the y-axis and choose the center of the base as the origin. The tank is half full, so this is 6. We pick one position and create the slice of water, or the slice of one layer that we're going to consider. And this is a position y. So y will be anywhere from 0 position to 6 meter position. This is in the y direction. So the thickness is dy. The cross-sectional area would be the area of the circle, or pi r squared. This tank has a radius of 4, so pi times 4 squared, which is 16 times pi. We pump the water up to the level 4 meters above the top of the tank, which is at the level y equals 16. So we lift the water up to that position. So this is a dy, or the distance lifted. The distance lifted would be the level 16 meters, which is 4 meters above the tank, minus the position of the water, which is the y. So the work equals the integral from point A to point B, or from 0 to 6, which is half tank, rho times g times the area, or cross-sectional area, times the thickness. Area multiplied by thickness is the volume, and then multiplied by the distance lifted. Rho and g are the constant. We take it outside of the integral for our convenience. Integration from 0 to 6. The area is 16 pi. The thickness is dy. The distance lifted is the capital D of y, which is 16 minus y. Rearrange the term for our convenience to compute. 1,000 multiplied by 9.8 multiplied by 16 pi. Integration of 16 minus y multiplied by the thickness, which is dy, integrate from 0 to 6. The integration 16 minus y would give you 16 y minus y squared over 2. Evaluate from 0 to 6. That will give us 16 times 6 minus 6 squared over 2, subtracted by 0, or 78. And then we join with the numbers outside of the integration to give us 1,000 times 9.8 times 16 pi times 78, which is 3842934.79 as the value of the work required to empty the tank where the water is half full of the tank.